Okay, picture this. You take the world's top 5 AI coding agents and throw them headfirst into a massive, chaotic, completely real-world legacy system. What actually happens? Well, today, in this explainer, we're cutting straight through the marketing hype. We are getting right down into the trenches to see exactly how these advanced coding models handle the messy, unpredictable reality of older code bases.
We've all heard the pitches, right? The vendor claims that their newest, shiniest AI can seamlessly understand your entire code base in seconds. It honestly sounds like magic. You just point the AI at your mountain of tech debt, press a button, and watch it all modernize. But we're going to look at what actually happens when they are put to the ultimate stress test. Because as anyone who has worked in tech knows, legacy code isn't just old code. It is an entirely different beast altogether.
180,000, take a second to let that number sink in. That is how many lines of 12-year-old, totally undocumented code we're dealing with in this test. 180,000 lines. This wasn't some sterile, perfectly clean lab environment or a neatly packaged GitHub repo. This was a massive, sprawling, real-world monolith. And the constraints here are what make this so fascinating, because this environment perfectly mirrors the chaotic reality of actual legacy projects. We're talking about a wild mix of legacy PHP and half-migrated Java, a database schema with literally 0 foreign keys, absolutely no test coverage on the core modules, and the distinct, clashing quirks of 3 entirely different generations of developers. And the absolute kicker? 0 additional documentation was provided to the AI. They had to figure it out purely from the source code, exactly like a brand new developer joining a chaotic project on day 1.
So, in this explainer, we'll quickly break down the legacy code test itself, grade our 5 AI contenders, uncover the one massive blind spot they all share, and then wrap up with a layered strategy for actual success.
All right, let's jump straight into part 1, the legacy code test, where the goal is identifying technical debt and refactoring it without breaking the system's behavior.
Moving right along to part 2, we are going to grade our 5 agents, Claude, Cursor, Copilot, Devin, and Windsurf, as they face down this monolith.
Now, the task given to each of these agents was simple in theory, but unbelievably hard in practice. They had to review the code, find the technical debt, and safely refactor the payment module. But before we look at their grades, you really need to understand the vast differences in how these tools operate. You have local refactoring tools on one hand, which make fast, in-editor, file-by-file changes, and on the other hand, you have end-to-end autonomy. These are agents designed to plan, write, and test across multiple files completely unsupervised. They are totally different paradigms of AI assistance.
And it is super fascinating to see exactly where each of the 5 leading agents thrived and, more importantly, where they spectacularly failed. As you'll see, every single one brought a unique strength to the table, from Claude's top-tier reasoning to Devin's total autonomy, but they each hit a very specific, catastrophic blind spot. Let's break down exactly what went wrong for each one.
Let's start with Claude Code. We instantly see a glaring issue. Strong reasoning cannot save you when the business context lives in a legal PDF, not in your code repository. So Claude produced this amazing step-by-step migration plan. But during its review, it found a hard-coded 3% discount in the payment module with no comments attached. To a logical AI, that looks exactly like a bug, right? So it just removed it. But that 3% was actually a negotiated contract term with a specific vendor. If this change had been pushed to production, it would have been a massive financial and legal headache.
Then there's Cursor. Unbelievably fast, excellent local refactoring, but that actually became a liability. Why? Because legacy systems almost always fail at the seams between features, which is right where Cursor's context window ends. Cursor was fast and clean at restructuring one specific function. The problem was that exact function was called from 4 other places in that huge codebase, and each place had different input assumptions. Cursor broke 2 of those call sites completely silently, so it optimized the file perfectly but shattered the wider system.
Next up is Copilot Agent Mode. Now, Copilot treated all code smells as equally important, which is exactly backwards for legacy risk management. In legacy code, priority is absolutely everything. Copilot made really great, reviewable pull requests, sure, but it spent all of its time cleaning up minor formatting and variable names, and it completely ignored a critical, unvalidated user input path in that exact same module. It just lacks the human context to know that a glaring security vulnerability is infinitely more important than messy indentation.
Enter Devin. This proves that in a legacy system, autonomy without calibrated uncertainty is a massive liability, not a feature.
Devin was the most autonomous of the bunch, running entirely unsupervised. But when it encountered a really confusing config flag that was used in 3 places with totally contradictory logic, it didn't stop to ask for help. It didn't flag it, it just confidently guessed. And let me tell you, in a fragile legacy code base, a confident guess is incredibly dangerous. You want an agent that stalls and throws up a warning flag, not one that barrels right through it.
And finally, Windsurf. This one reminds us that even the most auditable AI is still fundamentally just reading code. It is not reading the organization. Windsurf was actually fantastic for tracking what was changed and why. But it deleted a quote-unquote temporary workaround from 6 years ago. What the AI didn't know, because it wasn't written anywhere in the code, was that the finance department's entire downstream reporting system had become completely dependent on that specific, janky workaround.
Which brings us to part 3, the universal AI blind spot. Let's look at the overarching pattern of failure across all 5 of these agents.
Because here is the real kicker. While every single agent was great at reading code, they all failed in the exact same structural way. It literally didn't matter if they were local assistants or fully autonomous agents. Legacy systems are built on institutional knowledge. They're built on knowledge scattered in random Slack threads, inside departed employees' heads, and on workarounds that were never documented because, well, everyone just knew how it worked. AI coding agents only know what is in the repository. They can't read your company's Slack history, they haven't read your vendor contracts, and they certainly can't interview the lead developer who quit 3 years ago.
This really highlights the core failure mode. AI agents cannot map technical debt to actual business risk because they completely lack visibility into business intent. This is the true definition of business logic in a legacy system. It is all the undocumented rules that dictate how a system actually functions in the real world. Think about it. If the AI removes a piece of code that looks completely useless, but it's actually there to uphold a crucial compliance law, you don't end up with a better code base, you end up with a lawsuit.
So how do we actually fix this? Part 4, a layered strategy for success. Because at the end of the day, modernization really is business transformation. Now that we've busted the myth of the omniscient, all-knowing AI, we need a massive mindset shift. We have to move away from merely trying to pick the smartest tool and instead focus on preparing our organizational context so that automation moves safely, not just quickly. If you just grab an AI tool, you are moving incredibly fast, but you're moving blindly. Intelligent business transformation means pairing that lightning-fast AI execution with a structured human understanding of what your business actually depends on.
So here is your practical blueprint moving forward. First, you absolutely must document compliance and contracts outside the code before you ever let the AI loose. Second, treat these varied agents as stages in a pipeline. Use Claude for your big picture planning, Cursor for the quick local refactoring, Copilot for pull requests. They aren't competitors, they are a team. Third, actively force the escalation of ambiguity. Keep humans at the key decision point so the AI never has to guess. And fourth, always let human-led business risk dictate the priority, not just what code looks the messiest.
Given that every single tested agent made at least one production-breaking error, I want you to ask yourself this one vital question before unleashing AI on your own legacy monolith. Who is translating your business context for the AI? Because AI can write and refactor code faster than ever before, but it is ultimately up to you to tell it how your business actually works in the real world. Keep that in mind as you plan your next major refactor.